Hey guys, it's Mr. Ray here with the second part of our grade 9 review. So in this video I will be doing day 3 and day 4 of the grade 9 review that's been posted, and it's like I said on the first video, um, this is homework for you to be handed in through Brightspace. So the day 3, which is everything except the last page here, is primarily graphing linear equations. Okay, so just as a recap, and I'll explain each of these in detail, there's 3 ways of graphing a linear equation. One is a table of values. Now when I was growing up, that was pretty much all we did. But there's a couple other methods. One which I think is the most important, and in this review they call it quick graphing. But it basically just uses the slope and y-intercept. So it might have that name, slope y-intercept graphing. And then the third one is using the intercepts. Okay, this one's probably the least used, but there's some cases where, based on how the equation's given to you, this might be a quick way of doing it without rearranging your equation that gets you the graph. Okay, so in this example here, they want us to do a table of values. So just a reminder of how to do that. So we're graphing y equals 3x minus 2. So that means we've got these given values of x, and we want to calculate the values of y. So we're given these different values of x. We want to find out where's the point along those vertical lines. So you could do this. I'll just show you the first couple here. So we have 3x minus 2, but the x is negative 2. So I replaced the x with negative 2, and then the minus 2 from there. So that's negative 6 minus 2. That's negative 8. And you just keep going here. 3 times, now it's negative 1 for x, and then minus 2. That doesn't change. That's a constant. So that's negative 3 minus 2. That's negative 5. Now, once you know how to do the table of values, especially if you remember, that's the slope and that's the y-intercept, right? Okay, so if you're doing a table of values where the x value goes up by 1 every time, that means once you've done your first couple of y values like we have, you know that y should be going up by 3 every time because that's the slope. And that depends that this is going up by 1, this should be going up by 3, and you can see in this case it is. So negative 8 to negative 5, this should be negative 2, this should be negative 2 plus 3 is 1, 4, and 7. Okay, so that's a good way to use the slope once you've started your table of values. It's a little tougher if that's a fraction, but it still works. So now you can take these points. So remember, we've actually created 6 points here. So we created the point negative 2, negative 8, negative 1, negative 5, 0, negative 2, 1, 1, 2, 4, and 3, 7. So those are all coordinates of points that are on the graph of this line, this equation of a line. Okay, so now we can take these points, plug them on the graph. So I've got negative 2, negative 8. So that's go to negative 2 down to negative 8. Got that. Negative 1, negative 5. And as you're drawing this, you're kind of looking at the graph going, I hope this is a straight line. And it looks like it is so far. 1, 1. Sorry, that should be 0, negative 2. Then 1, 1. 2, 4. 3, 7. And you can see, just like the coordinates here, you're going up by 3 every time you go right 1. Okay, so and that kind of defines the slope. So I'm going to use my other pencil here. Don't happen to have a ruler. And I'm going to put my pencil on one of the end dots and then line it up with the dots and then draw a line all the way through. Okay, now you notice I did my line from, right to the edge of the graph. So even beyond the points I had, because a straight line just keeps on going in both directions. And I put an arrow at both ends to show that it does keep going. Okay, I don't want you to do a graph where the arrow just goes up to here. Okay, you know that the line just keeps going. Okay, if you ever had something where the line, there's a bump or something, you should probably go back to your points, or at least see if you made a mistake when you graphed them, like I did with that one point. Okay, because every linear equation has a straight line graph. Okay, so that was table of values, and this is the quick graphing. This is the one that you should use, probably 80% of the time, I would say. So the way that works is we basically take our equation and we grab the slope and the y-intercept and use it to make our graph. So in this case, so it's telling you figure out what m is. M is the slope, b is the y-intercept, and then I'll show you what we do from there. So I'll do a couple of these. The first one, so I'll put it over here. So m equals 2 and b equals -4. So we got the 2 from there, and the -4 is from the b value. Okay, so this one's pretty obvious. So b is the y-intercept. So y-intercept is equal to -4. And I can go right to my graph. Remember, the y-intercept is along the vertical y-axis, and I can make my point there. So I've already got a point, and now I'm going to use that as my kind of my anchor point or reference point, and start making points from that point. So the fact that this is a slope of 2, positive 2, okay, and I'm going to write that as a fraction, 2 over 1. Okay, so what that tells me, remember the top of the slope is rise over run, so it has a rise of 2. Okay, so a rise of 2 means up 2. If it was a rise of -2, it would mean down 2. If it was 3, it would be up 3. So it's up 2, and you should always make the bottom, like I mentioned on the last video, you should always make the denominator positive. In that case, this would be right 1. Okay. Now, so up to right 1 gives us the direction or the recipe to find more points. So I'm going to start at my y-intercept down here, and I'm going to go up 2. So I go from -4 up to -2, and then I go right 1. So that makes a little triangle, just like rise over run. So up to right 1, there's my next point. Keep doing that, okay? Go from this point up to right 1. Once you've done the first one, the rest of them are very fast. Up to right 1, up to right 1. You can keep on going and get lots of points, okay? Now, here's a little extra piece of information. Sometimes, say for example, instead of a y-intercept of -4, we actually had a y-intercept of 8. Well, that's not going to give us many points. We'll get the y-intercept and that point. So what do we do in that case? Well, when you get this instruction for additional points or recipe, there's actually an opposite instruction that works too. So if I keep these numbers the same, but change the direction. So instead of up to, it's down to. And instead of right 1, it's left 1. So that also works. And you can see I could, if I wanted to, I could go down to right 1, down to right 1. That's giving me all the points on the left side of the graph, okay? But you only really need 3 or 4 points, because you know this is going to be a straight line. So when I put my ruler out and draw my line, I get that line there. Okay. Now, this one here, I wanted to cover this because let's just talk about, I might not graph this one, but I want to talk about it anyways. So that is y equals 4/3 x plus 2. So that's the 4/3 is our m. M equals 4/3. That's our slope. And our b value is positive 2. So that means y-intercept is 2. Okay, so we could right away go plot our point there. Now, how do we handle this fraction? Well, it's the same way we did this, except, you know, we actually have a number on the bottom instead of 1. So what are the instructions for that? Well, that top is the rise. So positive 4 means up 4. And now the bottom part, that's a positive 3, that means right 3. Okay, so when you're graphing this one, you go right 4 up 3, right 4 up 3. And the opposite direction to go to the left would be down 4, left 3. Okay, so that's all you need is the y-intercept and the instruction how to build other points from your slope. So that's how these will work. Don't forget, if it's a negative value for your slope, again, put the negative on the top, like I've said. So if the rise is -1, that means you're going down 1. Okay, if it's a positive number on the top, it's up. Okay, so that's how you do the quick graphing. For me, it's by far the best method, quickest, and you know, it actually makes a lot of sense. Okay, and it's good when you have especially good when you have a slope that's a fraction, because when you try to do a table of values with fractions in it, it can be a little bit irritating. So this is the third method, and this is using intercepts. So here's the important part about intercepts. You'd probably only use it when you had an equation where the x and the y are on the same side. So this is not slope y-intercept form. So you have 2x minus 3 minus 6 equals 0. So here's how you would do this one. So remember, we can determine the x-intercept and y-intercept. To find the x-intercept, sub in y equals 0. So what that means, okay, so if I'm looking for the x-intercept, okay, what that means is I go to the equation and I'm going to set y equals 0. So there's the y. So that's going to change to 0. So what happens to this whole thing? Well, that's 0. So it's basically not there any longer. So what I do is I just kind of cover it up with my finger, and I get what's left over there. 2x minus 6 equals 0. So I just write the new version when y is equal to 0. And if I solve for this, that eventually would tell me x equals 3. So what does that mean? Well, that's the x-intercept. So the x-intercept is 3. So the x-intercept's along here, because this is the x-axis, and it's going to be that point. So there's a point on the line, and not, if we're graphing a line, all we really need is 2 points, as long as we don't make a mistake. So to get the y-intercept, it's the opposite. So to get the x-intercept, we let y equal 0. To get the y-intercept, we let x equal 0. Okay, so how does that affect our equation? So if x is 0, this whole thing's gone. The 2x is gone. So all we have left is -3y minus 6 equals 0. So you notice we got rid of the x. So that's -3y equals 6. So y equals -2. So that's the y-intercept. So I go on my graph. Y-intercept is along the y-axis. So now I have these 2 points. I have the x-intercept and the y-intercept. And I'm going to draw the line through those two. It's a lot better when you have a clear ruler. Okay, so arrows at both ends, and there's my line that has that equation. Okay, so that's the third method. This one's probably the least used, but there are some cases where if you're given an equation like that, you just want to do a quick graph, you just find the x and y intercept. Okay? Now, there's some cases where maybe we get the equation not in slope-y-intercept form, but maybe they ask us a question like, well, what's the slope of this line? Okay, so we really do want to rearrange it so that it is slope-y-intercept. So in this question, they actually ask us to rearrange and then graph. Okay, now we could graph it fairly quickly without converting, rearranging, but in this case, let's convert it and then change the form and plot the graph. So here's our original equation: 2x plus 3y minus 12 equals 0. So when you're rearranging for slope-y-intercept, you want it to be looking like that. So we basically want this term all by itself on the right, which means we don't want these two terms. So I am going to do a couple of things at once. So I'm going to leave the 3y there, but I need to subtract the 2x from both sides. So when I subtract it from both sides, that's gone, but when I subtract it here, I get negative 2x. Here, this one here, I'm going to add 12, I'm going to add 12 to both sides to get rid of this. So when I do that, this is canceled out, and I get a plus 12. So we're pretty close here. We got the terms in the right place, but we have 3y. We want just y. So we're going to divide everything by 3. So when I divide this by 3, it turns into y. When I divide this by 3, negative 2/3 x. And when I divide this by 3, I get 4. So this is now in slope-y-intercept form. It would actually be the exact same line as this, but now we can refer to it. We know the slope is, m value is negative 2/3, and the b value is 4. So that tells us the y-intercept is 4. So we go down, go to our graph. There's a point. And then the slope is negative 2/3. So remember, that's rise over run. So a rise of negative 2, since it's negative, that means down 2. So down 2. And since that's positive, that means right 3. And the opposite instruction would be up to left 3. So let's see if we get enough points doing just the first one. So down 2, right 3. So down 2, right 3. Here's our next point. Down 2, right 3. Down 2, right 3. Okay, and you're looking at that. It better be a straight line, otherwise something went wrong. And I'm drawing it all the way through the graph, even the area I didn't have any points. So there is our graph. Sorry for the glare there. Yeah. So, and we could have done this with intercepts. We could have looked at this and we would have got, y-intercept of 4 and x-intercept of 6, I think. Yeah. And we could have just got those 2 points and graphed it, but now we actually know the slope. It's a little safer doing this method anyways, because you're getting lots of points instead of just 2. So that's how you would rearrange an equation so you get it into slope-y-intercept form. I think I'm going to skip this one. We did something like it earlier. So this is using table of values. So you're going to calculate the y values. And then you get in this case, you're going to get 6 points. Put your 6 points here. Make sure it's a line. Draw your line through it. Okay. This one here, graph each of the following. Again, now, yeah, so this is important. They actually mean they want you to use quick graphing, which is find the slope and the y-intercept, because all of these are in basically slope y-intercept form. Now this one's strange, but maybe we can talk about that. So the value, what's the value of m there? Well, what's in front of the x? Well, there is no x. So that means there's 0 x's. So in this case, m is 0. And that number there, the constant, will always be the y-intercept. So the b is 8. Okay, so you just graph it with a slope of 0. So that means you could say 0 is the same as 1. Okay, so if you're doing your points, once you've got your y-intercept, how do you build the other points? Well, that's a rise of 0 and run of 1. So basically that's, up 0, right 1, up 0, right 1. So you're not actually going up or down. So the line is a horizontal line, and basically every point has a y value of 8 because it's not going up or down. Okay, so that's a special case. This is another special case, and this is a pretty strange one because you can't convert it into, you can't figure out what m is, and you can't figure out what b is. Okay, so you don't even bother. If it's x equals -5, that means every x value is -5. So it's basically a vertical line going through -5. And the reason why you can't get a slope for something like that is a vertical line. If you ask yourself, like, off a cliff that goes straight down, if somebody asks you, well, how steep is that cliff? Well, you can't really define it because it has no steepness. It's like a free fall straight down. Okay, so watch out for those cases. This is a vertical line and this is a horizontal line. This is another example of x and y intercepts. So you can actually do these fairly quickly once you know how to do it. So if I want the y-intercept, okay, I set x equals 0. So when x is equal to 0, 4y equals 16, or y equals 4. If I want the x-intercept, I set y equals 0. So it becomes 2x equals 6. Sorry, you couldn't see that. Let me just repeat that. So if I want the y-intercept, I set x equals 0. So it becomes 4y equals 16, or y equals 4 when I divide by 4. Y-intercept is 4. Well, if I want the x-intercept, I set the y equals 0. So 2x equals 16, or x equals 8. So that's a very quick way of graphing that because of the form it's in. Okay. These questions here, number 4, these are basically rearranging like we did on the previous page. We want to get it to y equals mx plus b. So let's just do this example here. So in this case, 3y equals 6x plus 9. We want to divide everything by 3 because it's already got the y term by itself. So we don't have to get rid of any terms, but we do have to divide everything by 3. So in this case, we'll get y equals 6 divided by 3 is 2x. 9 divided by 3 is 3. So that's basically that. These lines are exactly the same, but in this version, you can actually see the slope is 2 and the y-intercept is 3. Some of these other ones, I think all of them, you'll have to actually move the terms around. So for example, this one here, you want to keep 6y on this side, but you want to get rid of these two. So you're going to subtract 3x and add 12. Okay, so you'll end up with 6y equals -3x plus 12, and then divide everything by 6. Okay. Yeah, I'm gonna try your hand at these two. The only thing I'd say about these, we talked about modeling equations in the math as a language video, but in this case, you've actually got two unknowns. Okay. So, write an equation relating the total cost and the number of games played. So these are the two variables. So the total cost will be, you could call capital C, and the number of games played. You could call little g or x or whatever you wanted to. So build the equation using that. So the equation will start off c equals something. So try that. And this one's kind of the same idea. So try those. We might take those, probably take those up in class. And last page here. Okay, so this is these are good questions here. Unfortunately, there's only 2 of them, and that's determine the equation of the line from the graph. Okay, so remember, if we want the equation, we need the slope of the line and the y-intercept of the line. So let's look at this one here. So what we always want to do is find 2 points on the line that are exactly on the intersection of 2 integer values. So this one's perfect because we've got a point, basically an x-intercept there and a y-intercept here. So it can't be points that are close. Like you would never pick, a point around here. That one looks like it's close, but we're not sure. But the points every second value, you don't guess. You don't say, well, that looks like it's, 1.5. So let's pick these 2 points, and from that, what we do is we kind of build a triangle for our rise and our run. Okay, so in this case, you ask yourself, I'm going from this point to this point. Okay, what's the rise and the run going from here to here? Well, I'm going down, so I'm actually losing. I'm losing the slope. Not the slope. I'm losing the height. My rise is going to be negative. So I started at 6 for the y value. I ended at 0. So this is y equals 0. So I went from here to here. So you can do 6 minus 0, which is 6. So the rise, which is on the top, is 6. And the run, which is from here to here, it's the bottom of the triangle. So 1, 2, 3, that's positive. 6 divided by 3 is 2. Now, I made a mistake there, right? So the rise is not 6, because I didn't go from here to here. I went down. I went from here to here. So that's actually a minus 6. So the slope is negative 2. And you can always tell from the graph, this is super easy, because if it's going down left to right, the slope better be negative. In this case, the line is going up to the right. That means that it definitely has a positive slope. Okay, but you should always check the sign once you calculate the slope. Make sure you've got it going in the right direction. So in this case, I found that and I corrected myself. I had the right number, I didn't have the right sign, and it was easy to see that, oh, I'm going down, so it's negative 6, not positive. So I've got the slope is negative 2. The y-intercept, that's easy to find. That was actually one of the points we used. So the y-intercept is 6, and make sure you get the sign correct on that. And now it's just plugging in your m and your b into your equation. So in this case, equation is y equals mx plus b, or y equals negative 2x plus 6. So that's the equation of this line. So try it with this. Make sure you pick good points, okay? So, a lot of times there's more than 2 good points. You can actually choose from quite a few, but make sure that you're not guessing. Like, for example, this one here, you wouldn't pick a point here because it doesn't intersect a nice x and a y value. I call it the crosshairs, right? So that would be a good point. That would be a good point. These would not be good points. This one might be. Okay, but make sure you got a lot of points to choose from. Make sure you choose good ones. Okay. Now this one here, write each equation in the form y equals mx plus b. So again, this is like what we were doing on the previous page. We're rearranging the equation so that we get, so I'll do g here. So I'll just write the question out. X minus 2y plus 6 equals 0. So again, I want to keep the y on the left, okay, which includes the negative 2. So what I want to do is subtract the x, and I want to subtract the 6. Okay, so I keep my negative 2y there. When I subtract the x, it's gone here, and it's minus x here. Subtract the 6 here, it's gone here, negative 6. And then when I divide everything by negative 2, I get y equals, now look at this, I got a negative divided by a negative, so that means it's positive. So it's actually 1/2. So I could have put a negative 1x here. Negative 1x divided by negative 2 is 1/2 x. And negative 6 divided by negative 2, again, changes the sign to plus 3. Okay, so there's your slope in the y-intercept. So slope is 1/2, y-intercept is 3. So that's what they're asking to do here, is rearrange. Okay, that's really good practice. Now these ones here, I'll just talk about them. So this group of questions says express each equation in the form. So this is really exactly the same as what we're doing here, except they want you to graph it. Just graph one or two of these. There's no point in overkill here. Obviously, you're going to need to write this on another page. Okay, and again, you've got question 4. It's got a bunch of equations that aren't slope y-intercept, but in this case, they're asking for the x and y-intercepts. So you do that technique where you graph using x and y-intercepts, find the x-intercept by letting y equal 0, find the y-intercept by letting x equal 0 and solving, and it should be pretty straightforward for these guys. Now, these are interesting questions. Which lines are parallel? So, in order to do this, you have to rearrange all 4 of these into slope y-intercept form, and then pull out the slope. So what do we know about parallel lines? They have the same slope. So you're looking for 2 or 3 or 4 that happen to have the same slope. You might have 2 that have the same slope and another 2 have their own same slope but different. Okay, so you actually have to do all 4. This question here relates back to these lines, and that's which are perpendicular. So maybe you remember from grade 9. So perpendicular slopes are negative reciprocals. So if you had a slope of, let's say, 2/3, okay, for your line, a perpendicular line would have I'll write it like this. This would be a perpendicular slope. Okay, we take the negative reciprocal. So flip the number part. So that's 3/2, and then also flip the sign. So it goes from positive 2/3 to negative 3/2. Okay, so if you see any relationships like that from these 4 graphs, 4 equations in part 4, you might see a pair of lines that are perpendicular. Okay, so you don't have to redo the work that was done here. You just have to compare the slopes in a slightly different way. Okay, and then these 2 are very similar. You want an equation of lines perpendicular to this line. Well, we have to rearrange, get the slope. Then we take the negative reciprocal. That's our new value for m. And the value for b in this case does not matter. You can make b anything you want. Okay? You can make 0, you can make it 100, whatever you want. Because there's an infinite number of lines that would be perpendicular to a line. And same thing here, write the equation of a line that's parallel. This is actually easier. Find the slope of this and then make another equation with the same slope. But this time you should change the y-intercept that this one had, because it's got to be a different line. It can't be the same line. Okay, and then this is just some more equation solving. So solve the equation and then check your answer. And that would be plugging in the value of x on the left side and right side, make sure they're the same. Okay, so that's it for the review for grade 9. I know there's a lot of stuff here, but you can kind of see the general themes. In this last 2 days, a lot around graphing and a lot about converting equations of lines, and again some more solving equations. So you can see what's important going ahead. Work on that. If you have any questions, please let me know. in class or online, and I'd be happy to help. Thanks a lot, guys.